He also has a blog, which I'm sure he will tell you a bit more about, because there's interesting stuff about vegetables, growing vegetables and gardening. That sounds pretty cool. I mean, that's what I'm doing right now because I can't go outside. So tell me about it later, maybe at the party.
Sure.
And Gianluca will be talking to us today about how to become a Gophernetes or Gopherneters. And I'm guessing this is something in between Go and Kubernetes. Making
Got it.
Here. Sweet. So without any further ado, I'd like to take this away, Gianluca.
Yeah, thank you. Thank you for the presentation. And yeah, I mean, as you said, like Gophernetes is like a word that tries to explain and brings together Gophers that also like do Kubernetes stuff. And I'm gonna go with my talk, so I will share my screen and go from there. So yeah, this talk is about how to become a Gophernetes, because as you can imagine, it's a skill that you have to develop and leverage daily, try to figure out how it works and how to get better to it. And we also got, thank you for Meg from Packet, a nice Gopher that has a Kubernetes logo on it. So that's kind of cute. So yeah, Kubernetes is hard, and it requires a regrettably large head. I would really like to bet it, but you know, it requires very, very like an attitude that you have to learn. It's a skill, and it's reasonable to have it so hard because it's complex and it does a very key job. It tries to make your application reliable without you even having to touch it too much, just with declaring some YAML. And it also helps you to declare your workflow, the one that you want with your team and your company. So believe me, it is impossible until you believe it is. So during this talk, we're going to try to fix it and make it possible. So what is a Gophernetes? And we are in Wonderland, so there are a lot of like weird people here and mad people, but Gophernetes is like a developer, a Go developer, to be fair. It doesn't develop application that runs on Kubernetes. I mean, it doesn't need to do that. It doesn't need to be a Kubernetes contributor. So you don't need to be like a Kubernetes maintainer to become a Gophernetes. You just have to build applications that use and leverage the Kubernetes foundation. So it's important to remember that one of the old disclaimers that Kubernetes had to have in its website was describing itself as a framework for building distributed system, and has every framework, it has building blocks. Like it's with and a shield. So where you can find Gophers? Usually they hang out in the Kubernetes Slack. So there is a Kubernetes for everything, and there is a Slack for everything, and Kubernetes has its own one where you can join other like Gopherneters, try to figure out how to build reliable extension for Kubernetes itself. And there are two main organizations, Kubernetes and the Kubernetes 6 organization on GitHub, where you can find a lot of code that relates in some way to the day-to-day work that Gophernetes has to do. So these pictures are here to scare you about the complexity of Kubernetes. But as we spoke about before, it's impossible until you believe it's impossible. So we're gonna make it easier. So those graphs, as I said, are here to describe something that is very simple at the end. And it's the fact that Kubernetes is a glue of APIs. Those APIs will make Go from the user, so the developer can use to interact with it. So the API that you leverage when you use the Qctl, for example, are like public-facing API, let's say, or user-friendly API that you can use. There are other like API that usually are in the underline of the kubelet that are more for machines. So I'm speaking about the CNI, the CRI, and the OCI standards that we will see a little bit later. So as I said, at the end of the story, it's very simple. You can see Kubernetes has like a glue of APIs, and some of them are really friendly, the one you can use like the Qctl, as I said. Other ones are a little bit more, in the foundation of the Kubernetes itself and how it interacts with other components in the machine itself. So the API server is the one that we usually leverage with the Qctl. The other one is a little bit more like down the stack are the CRI, the container runtime interface, that is the API that allows Kubernetes to speak with different underlying container providers, let's call them. Kubernetes call them runtime. The most popular one is Docker, Containerd, CRI-O, and many others. There is also another API that helps you to manage networking. So the CNI, the Container Network Interface. And we have a lot of them. They are based to cloud providers or to the underlying technology like PPF or whatever you like to use. So Calico, Flanner, Cilium are like some of the popular ones, just to give you a brief idea about where we are. And another one is the container storage interface. So Kubernetes runs application, and usually application needs to store their state at some point in some place, even if it's a small state. And it highly depends on the cloud provider where you are to. So everyone serves its own one. So Amazon has an ABS one, Packet has a CNI one that use the storage that Packet provides. So all those abstractions are here to help you, or has a Gophernetes, to implement the workflow we like. And workflow is something crucial that we're gonna like build and look around over this talk. So a little bit about myself. I'm Gianluca. I'm a Gopherneters at Packet.com. I just joined recently. And as it says, I have a blog and I tweet a lot. So if you have any questions, like reach me out there as well, because I'm happy to answer them. When I'm not hacking, I grow vegetables, and I work from home for a while, so like 4 years now, and it is a very good way to wake up a little bit earlier, get outside, do some stuff, and get back to work. And I like to travel for fun and work, so now I'm at home for a while, but it's working good with virtual conferences and all of this community-related stuff. So see you around. And yeah, that's back to what a workflow is. So workflow is the reason behind why Kubernetes exists. It is the end goal for a good Gophernetes. So like we spoke for years about DevOps and the idea that developers and operations comes together to achieve the same goals. And everything has an API nowadays because cloud providers provide those. And the idea is to be able to glue them together to build something that we like to use, no matter of the environment, no matter of what we are trying to achieve. And I put some example of workflows that we have. Troubleshooting and debugging is a workflow. How do you or your team try to figure out what's going on in production? This highly depends at some point on your cloud provider or on your like orchestrator. But the user experience that you have to develop, the workflow, will stay the same or should stay the same, even if you move to another cloud provider, because the workflow is the bit that you like to use and you enjoy to use. It makes you safe. It makes you happy to do your job every day. Observability and how you build a data pipeline for logs, metrics, and traces is another workflow. It may change based on like the choice that a team and a company does, but it's still a workflow that we have to implement, and we have to implement in a good way. Delivery is a huge one. Like companies and teams invest like ages to try to figure out a good like workflow. There are a ton of them, like canary release, when you do a % of rollout, like blue-green when you keep 2 environments and you swap them all together. Progressive delivery, like feature flags and so on. And your own, like don't limit yourself. So everyone wants a magic solution for their problem, and everyone refuses believe it's magic. And That's true. There is no magic. You have to use the API, you have to use code and glue them together and make something that you are happy to use. So the Gophernetes here is the limitation. So our ability to write codes that achieves and fix the workflow that we want is the unique limitation we have right now. I brought up a small report on already about how to extend Kubernetes. So there is a lot of code, a lot of libraries. I'm not going to go over all of them in details here, but the presentation is full of links, and the book has examples that you can use. It's free. You just need to leave your contact. So how do you extend Kubernetes in practice? There is a lot of ways. As I said, it's a blob of APIs. So you can hook it. You can hook your code wherever you like most. So it's an event-driven system. So when you do a Qctl create, a Qctl edit, a Qctl get and release, those stuff triggers an event, and everything can listen to those events and take action. Obviously, for resources that are native, like pods, replica set, deployment, stateful set, the event has a listener that does the actual work that you are supposed to that you see in the outcome, like the pod creation, leverage the CRI, the container runtime interface to create a container, and it leverages the CNI to give you the right network and so on. So shared informers are a concept that we will see in more details later, that allows you from the external with your code to watch for those events and add your logic to it. So for example, in the report, there is an example about how to label an Kubernetes node based on the label that the EC2, in my case, the Amazon EC2 has attached to it. So the idea is that to create a complex topology, you have to label your nodes. So you can use Kubernetes pod selector to place the pods in the right place. How do you do that? The easy way for me was to label my EC2, because I'm able to add labels to EC2 very easily with CloudFormation or with Terraform. And in some way, I want them to pass through Kubernetes. And the way I did it was with shared informers, because I hooked my code to a shared informer add node event. So every time that add node gets triggers, Kubernetes takes it and does the join, but it also triggers my code that look at the label of the attached to the EC2 and move them to the underlying node. So custom resource definition is another powerful way to extend Kubernetes. And the idea is that you can, like the native resource are pods, replica set, stateful set, ingress, services, all those kinds of stuff that you get for free. You can build your own and hook it inside Kubernetes, and it will give you the same flavor as the native one. So you will get them available in the Qctl get, describe, create commands. You will get them in the API behind authorization and so on. Those are super powerful, and they are not. There are a lot of ways to build them with Kube Builder or with your hands generating codes. As a Gophernetes, we have a big advantage because Kubernetes is in Go, so a lot of the code can be reusable from the Kubernetes itself. Another way is via a Qctl plugin. There is a typo on the slide that I see it. I will tell you about how they work later. And another one is a cluster API. Cluster API is the way you provision Kubernetes in a programmatical way. So the idea is you should be able to declare a Kubernetes cluster in the same way you declare a pod. Visionary? Not really, it's working. We have an implementation for Bucket that you can check out. So as I told you, as a Gophernetes, we are in a very lucky situation because Kubernetes is in Go, so there is a lot of code that is written in Go that we can reuse. And the community is doing a huge amount of work to separate the reusable bit of code from the core, so we can easily import it mod. One of them is the client Go. This is not really tied to Go. Every language has its own SDK, but the client Go one is like rock solid. It has all the built-in like capabilities like work queue that you can use to push your events, collect them, and execute them like later, applying back pressure and all those stuff. Client Go also gives you a REST client that you can use it to call the API. And if you have custom resource definition, you can use the client Go to leverage and use to consume the custom resource definition as a normal resource as well. So the CLI runtime is a very cool one if you use Kubernetes, if you write Qctl, or if you write binaries that that has to look like the Kubernetes CTL. And I'm gonna tell you why it's important in a bit. Another one is kind. Kind is a way to provision a Kubernetes cluster using Docker containers. So as you can imagine, it's super lightweight because it just requires Docker containers, and every node is a container. It has some limitation, but I use it a lot for testing because it can also be embedded as a library and programmatically write your test that depends on a Kubernetes cluster, like your end-to-end cluster with a real Kubernetes cluster. So as I told you, God, my hack is destroying me. The Qctl plugin, it's a very simple way to write your own code. And as you can see, it's that easy as writing a binary that can be executed. And so it has to stay in your path. And it has to start with the Qctl dash prefix. So every binary name has Qctl dash whatever you like, in my example is hello, can be executed by the Qctl, typing Qctl space, whatever you call your Qctl plugin. So in my case, Qctl hello. Now, this example is very simple, and as you can read, it doesn't even use Go. But with Go, you can do a lot of cooler stuff. And this is just here to screw the box. And you have to think outside the straight jacket that I have here. So think about how you can do a Qctl plugin, and I will tell you a few tips that I learned along the way. But before that, let's get out with a very complex concept that is the shard informer. So this is the piece of the code that I think is important that you have to know to get the flavor about how a shard informer works. So it depends on the client set. The client set is the actual client that you use to interact with the Qctl. It usually gets configured and authorized as well. So as you can see, you can add the event handler, and the event handler watch for add, update, and delete. And look at that. It's like the Qctl edit triggers the update, the Qctl create triggers the add, and the Qctl delete triggers the delete. So every time a resource gets removed or updated, it calls your code here. And as you can see, the informer is tied to the resource. So factory.core.v1.pods.informer gives you an informer that will trigger your code when a pod event happens. You can do the same with the deployment or stateful set or whatever, just what you want. And you run it, and you can use context and channels to manage termination. So the UI is crucial. We have to keep it as close as possible with the Kubernetes one. And in order to do that, authentication is a key factor, because as you know, there is a kubeconfig environment variable by default. It is in your home, and that contains all the keys, all the context, all the authentication bits. And with the client CMD, that is a tool provided by the client Go library, you can mock and you can emulate what the Qctl does for your binary, because that's easy. So we can not only mimic, we can do the same stuff that the Qctl is doing. Why it's important to be friendly when we develop code that people have to use in the context of Kubernetes? Because people and companies spend times, hours, years to learn Kubernetes. And if you give them a CLI that is integrating the Qctl, that works in the same way, that has the same flavor, you are ahead of the success of your project. And the integration of your workflow will look like not far away from a Kubernetes native component. So flag are crucial here, because when we do CLI, flags is the way we speak with binary. And the CLI runtime libraries gives you a set of utilities that helps you to reuse flags, the same flags you have in the Qctl. And when I speak about flags, I mean label selector. I would like to use, when I have to select something in my binary, I would like to use the same flavor that I have in the Qctl. So -hel or -- selector with an array of key value pairs. Namespace selection, -n, -- namespace. Or I want to get all the resources for all the namespaces, -a or -- all namespaces. When I have to change authentication and configuration, I want to use --qconfig. The output, I want to use -o, because that's how it works in Kubernetes. There is a bit of code that I will leave you, but this is an example that I wrote a Qctl plugin, open source, and used this mechanism with Cobra and PD flags. So as you can see, it's not far away from the most common libraries that Gopher use all days. Another important things you have to do if you develop something open source, but also closed source, because Crew can be used like internally as well, is to make it easy to install it. And Crew is a Kubernetes SIG project that helps you. It works as a package manager for Qctl plugins. So with a simple Qctl Crew install, you can install like cool plugins for your Qctl. The CLI runtimes also gives you a set of utilities to print tables as the one you have when you do Qctl get. I never use it. It's not super simple. I will blog about it as soon as I have a chance. Production is a dangerous place, and usually it's a very hard it is our fault. It's too complex. It is our fault as operator if it doesn't work how it should work, because it means that our workflow are not well implemented. And if you use Kubernetes as the way to interact with your infrastructure, you get a lot of stuff for free. Some of them we already spoke about. You get a consistent API and a solid ecosystem to interact with those API. Client Go, all the other Kubernetes as they work. Your you can almost you can do user store CRDs, customer resource definition, gets all in this workflow for free. So we are at the end of the presentation, and as I said, there are a lot of concepts, a lot of code, and I blog a lot about it. The first link is about the category of my blog that contains more detailed articles, code, and so on. The second one is a book, is the report I wrote. The third one is a book that covers like shared informers, CRD, and so on. And yeah, that's it. Thank you for listening. I think I'm gonna. That's it. Looks like I can't hear you. I don't know why.
I know why, because I muted my microphone.
Okay, that's great. Now I can hear you.
Awesome. Cool. All right. Thanks so much for the talk. Sorry for the audio problems we had in between. I don't know if you noticed, Gianluca.
Didn't. All fine for me, so.
Okay, good to know. Yeah, thanks very much. I'm checking the chat for questions right now. They were mainly about the sound. Okay, so if you have any questions, you can send them in now. Is there anything, Gianluca, that you would like to share that you didn't share in your presentation, like any tips maybe, or like best practices or FAQs, anything like that?
Yeah, I mean, as I said, like there is a lot of code that we luckily can use in Go because the ecosystem is all Go-based. But all this code makes the life of a developer that wants to write very good Kubernetes integration hard because there are so many ways, so many repositories. The best way you have is to look at other open source projects. Like there are a lot of open source like integration already done that use CRDs, then use Qctl plugins. Some of them are linked in the slides as well. So look at the code, copy that, figure it out. And if you get stuck, like there is a huge community in the Kubernetes Slack that is always able and happy to help. So I ask their question every time. I try to answer when I know the answer and so on. So just join us there and have fun.
Awesome, thank you. So we're almost up with the time, but I have one last question. What vegetables are you currently growing?
Yeah, now I'm taking care about tomatoes a lot because they have a long story. Like in my family, we used to keep seeds from tomatoes over the years. So yeah, now it's my turn to try to keep them alive. So
yeah,
it's a huge responsibility.
I bet you're making an awesome marinara sauce.
Oh yeah, every year, yes.
Awesome. Okay, thanks so much. I hope you'll be sticking around on Umbrella. So if anyone has more questions, they can like book a meeting with you or try to grab you in the chat.
Yeah, sure. See you there.
Awesome. All right. So we'll be taking a 15-minute break on this track. And then after so at 11:45 my time, we'll be continuing with Alex Ellis from Open FAS. And he's going to talk about bare metal, how to introduce bare metal to a cloud native world. So thanks all, and see you in 15 minutes. Thanks, Gianluca.
Bye.